So with tier storage, instead of adding more compute, unnecessary compute, idling compute, you are able to flush the necessary data directly in something which is much more cost efficient, of course with certain trade-offs we can discuss later, but definitely opens the use case where you can just sync more data, actually infinite amount of data, into something which will take care of it.
You're listening to Data Revolution,
the show about data, innovation, and economics in the rapidly changing cloud world.
I heard you sat down with Filip and Josep from Ivan. So could you tell me a little bit more about what you talked about?
Of course, I had the pleasure of sitting with Ivan, director for open source, and with Filip, which is the head of our streaming platform. And we went through the journey of something called tier storage, which is a way to basically decide and divide your data depending on your needs. We discussed tier storage in the context of Apache Kafka, which is a streaming platform. And we were able to understand how tier storage gives to Kafka amazing abilities when it comes to agility and experimentation, and also the ability to do a little bit more. Then with Filip, we tried to see the future of this. And we went into understanding how storing data in different ways could also be used to store the data speaking multiple languages. So we don't actually need to store the data only for Kafka to write and read, but if we do things smartly, we can store the data in other formats that are more universal. It could be Parquet, it could be Apache Iceberg. This enables kind of a new wave of seeing Kafka, because it allows you to use Kafka as the basic technology to ingest your data, and then how you query the data, how you use the data, you will have different tooling depending on your data needs. So I believe the interview overall was really interesting to see how there is a paradigm shift on how Kafka is and will be used in the future.
That sounds really great. So I actually used to be in analytics for a few years when I was at AWS, but it's been a while, so I'm really excited to listen to what you all talked about. So let's just get to it.
Yep. Josep, Filip, it's a pleasure having you here. In this episode, we will talk and check what is the status of tier storage for Apache Kafka, and we will try to look at what is the future of streaming. So let me start with Filip. Can you tell me what is tier storage and why should I care?
Francesco, really nice to be here, first of all. To explain tier storage, I think we need to take a step back and just say a little bit about Kafka. What is actually Kafka? And I'm often asked the question, like, what does Kafka do for my business, right? Because we can always go into the technical jargon and deep dive into what a partition is and what is a producer, etc. But usually this doesn't really give us the full story. So Kafka is a system which allows businesses to connect, stream, process, and actually run real-time data and real-time processes across their stack to actually operationalize and execute on real-time use cases. And when I say use cases, I really refer to those use cases which are requiring a certain level of real-time decision-making. So I'm referring usually towards the use cases which are actionable, preventive, proactive, stuff which needs and requires immediate attention. And why? Why is that, right? Usually business happens in the here and now. It doesn't happen after the fact, right? And this is what Kafka actually gives you. It's a platform, it's an ecosystem, an open source ecosystem, which allows businesses to construct real-time experiences for their end users and actually harness the power of real-time interactions to power their products. So, to go back to your question, tier storage.
Wait. You're doing my job now. You can go on.
Tier storage actually makes Kafka more agile. And it's one of the most important steps for Kafka to become more cloud-native system. We need to remember that Kafka was designed many, many years ago, and it was designed for the data center. In the data center, you never needed to pay for any, let's say, local disks. It was basically everything included in your, let's say, total infra bill. And in the world of the cloud, this is not the case. You actually always deal with cloud primitives. You can mix and match, but also this comes with its costs, right? And also new capabilities. One of those capabilities is the object storage. Object storage is one of the most important breakthrough innovations in, let's say, in our cloud world. And what Kafka does with tier storage is starting to leverage a new type of storage for its operation.
If I understood correctly, Kafka is a streaming system, so allows me to move the data from A to B with almost zero latency. And then tier storage allows me to store the data not locally where Kafka is running, but on a separate storage. The question that I have is, why does that make Kafka more agile?
Oh, that's a great question. Actually, we need to understand what problems the local storage actually brings to Kafka, right? There is a certain theoretical limit for each of the Kafka servers, and we call them brokers, actually can hold in terms of local data. Some people can say it's 10 terabytes, some people say it's 12, but the reality is that you will start getting diminishing rate of returns the more storage you add to a particular broker. And what usually drives the operator to do is actually horizontally scale, add more brokers, right? If my storage needs grow, I need to actually horizontally grow Kafka. But when you grow more nodes, what happens? You need to buy the necessary compute for those nodes. So you're actually buying idling compute when you actually need, what you only need is actually storage. So with tier storage, instead of adding more compute, unnecessary compute, idling compute, you are able to flush the necessary data directly in something which is much more cost efficient, of course, with certain trade-offs we can discuss later, but definitely opens the use case where you can just sync more data, actually infinite amount of data, into something which will take care of it.
Does it help also when you need to reshuffle a cluster? And I believe this is kind of a common operation.
Absolutely. One of the key operations any operator actually needs to pay attention to running Kafka is whenever you do any kind of change on the cluster, you always need to keep an eye on the balance of the data between the nodes. And the more data, the more you need to rebalance. In certain extreme cases, a rebalance can take anywhere from a couple of hours to days. And during this time, the cluster is in a vulnerable state, right? It means that it does not operate in a stable, it's not in a stable state. So during those times, the operator is, or maybe will experience certain issues which, let's say, will eventually translate into degraded performance for the end customers, which we all know that Kafka is a critical system to any business, so we want to avoid this at all costs. So in such a situation, being able to offload the data from those local disks into something which is, let's say, decoupled from the runtime of Kafka is proving very, very beneficial because it's simple physics. The less data I have to rebalance, the faster the rebalance will actually finish, and the quickly we will become to a steady state.
Basically, what you're saying is that instead of each broker, each server in the Kafka ecosystem having a bucket with a lot of data, we have a hole in the bucket and the data is going to S3 or some sort of cloud storage, and then we only need to rebalance the sand that is kept in the bucket.
Yes, if we think about it, but I will actually take it a step further, and I would say that actually this hose at the bottom of the bucket is pump driven, so we are able to push actually water back into the bucket if we want to. So It's not only counting on gravity in this case.
That's cool, I believe. I like when you build sandcastles. Josep, to you. So I've been in the streaming space for quite some time, and tier storage is not a news. I've been hearing about tier storage for years. Can you tell us a little bit of the history and how we came, what's the status as of now of tier storage?
Yeah, so I was looking at the dates precisely because I knew these kind of questions would come because that's a usual question that people might ask. I mean, tiered storage has been around for a while. I mean, you have been hearing about it for a while now. So it all started back in December 2018. And that's when people started discussing how we can have tiered storage on Apache Kafka. At that point in time is when the proposal was written in Apache's internal documentation side. And basically every change that you need to do in Kafka needs to have an improvement process. The improvement process means you need to write the proposal with pros and cons, design documents, change of APIs, you name it. And once you have this written, you need to discuss it with the rest of the community until you reach some kind of consensus. That point of starting to reach consensus started on February 2019, I'm sorry.
Yes.
2019, and we are not in 2029 yet, so I don't know where I'm living. Probably the clock was. So 2019 started the discussion, and it ended in 2021. So it was 2 years of discussion for this. That's a lot of discussion. And you can understand that what he was mentioning, Filip was mentioning that Kafka started as a tool that was running on your own data systems and your data centers. And we needed to move it to the cloud native understanding concepts. That's a big shift. And so there was a lot of things in Kafka that weren't working as they should. So there was a lot of things that needed to be polished. And that's what happened during these 2 years of discussion. Also, that's a heavy thing. Not all the parties involved wanted maybe to have this feature moving forward because they might have had some proprietary solutions, and having an open standard might go against their intellectual property. So that's why maybe some delay was added as well. But by the end of February 2021, we had the approval. So basically we agreed that makes sense. After the consensus is reached, we need to have a voting process where at least 3 people need to agree that would make sense to be added into the Apache Kafka. That happened, and it shortly after that one, and then it was again 2 more years under development for implementing Kafka tiered storage. And that brought us to October 2023, where we had the first releases where included tiered storage into the official upstream Apache Kafka. Right now, as the time of speaking, we have Kafka 3.7 series that are being released, and in there we have already a preview mode of Kafka tiered storage. And now people can go around, download Kafka, and try tiered storage together with the plugin. Because another thing that how it's built is Kafka tiered storage has implementation that goes into the broker, as Filip was mentioning before, which is the piece of software that deals with what data do I have and how do I know which data I'm having and which one I need to pass over to the next ones, and if I can serve this one back to my clients. But this code alone, this piece of code that is the broker, doesn't know how to upload things to the upstream, to the buckets, to the storages, for example. And that's where the plugin system comes into play. Kafka tiered storage, the broker, only knows that there will be a plugin that knows how to speak those APIs. And then each plugin will implement a set of APIs so you can write onto the right system. So then when you download Apache Kafka, you need to choose which plugin you want. You can go to Ivan and you can download one that has Azure, S3, and GCP. And then you can save in any of these 3 object storages in there. And you can go and try it.
Okay, so basically there are 2 components there. One is telling the broker that there are multiple ways or multiple places to store data, because you may want to keep the data locally if you need fast performance. You may want to offload some data to cloud storage if you want to, serve the data for a long time or to keep the data for a long time. And then there is the plugin. You are the chief of OSPO, Ivan. Can you tell me a little bit of how we help the community, and also maybe what do you expect from it, or what we can expect from the community going forward?
And I will do one more thing. I will tell you what we did together with the community already.
I didn't ask for that.
Yeah, I know.
If you want, yes.
So to start with, you said I'm the chief of OSPO, so probably we shouldn't use acronyms, or I want to explain what the acronym is. OSPO means Open Source Program Office, and what an OSPO does is really different for each company. So each company has the OSPO they need. And the OSPO that Ivan needs is an OSPO that focuses on upstream projects. So what we focus on is contributing to upstream projects to make sure that they are sustainable and that they have the right level of innovation as well. And that's what we do. That's why I'm here sitting talking about what happened on Apache Kafka T8 storage. So going back to the question, you're right, we have this broker, we have the plugin, and the broker, for example, as you were mentioning before, you're right, you have like several config values that you can tweak, so you can specify exactly at which point in time data starts not being saved just on your local disk, but then they will be removed from the local disk and be pushed towards this remote storage, and then they will be kept there either forever or until another deadline is reached. So you can also have these different cleanup scenarios. And as I mentioned before, we have the plugin that we developed for the community. So one of the things that we did to help support this, we saw that there was the development of T8 storage got into a standstill position at one point in time. When we detected this standstill position, we wanted to try to push the project forward. But we also saw that the end of the project was near, as in it was almost completed. It was only like the last steps seemed too hard to make, or maybe people were too tired at that point in time. So what we decided to do was we need to be ready for when this feature is there, so we can have a plugin that is fully functional the very same moment that the feature is released. Because, as I mentioned before, the broker code alone doesn't do anything. It will just talk to an empty box saying, you need to push things to a storage, but if there is nobody listening, nothing will happen. So we needed to be ready for when the broker implementation was done, that somebody was on the other side listening and actioning those requests.
So you need to create the electric plug and the cable.
Correct. So
I'm all for analogies today.
Yeah, so we needed to do that. So in order to do that, what we decided to go is do, again, some type of archaeology. And we looked at the forks that existed at the moment that they had some implementation of the T8 storage. And at that point in time, we had the Uber implementation, which is the main implementation of T8 storage. The problem with that implementation was that it was based on Kafka 2.8. And at that moment in time, we were already at Kafka 3.5. Numbers are meaningful and they mean things. And the fact that we jump from 2x to 3x means that there are breaking changes in between. And that's really painful. So many of the code that was written in that 2.8 branch wasn't working anymore on the 3.5 branch. So we needed to reconstruct some things. At the same time, we were looking around and we asked around in the community, and we saw that LinkedIn had another experiment where they ported this 2.8 code into the 3.0 branch. So they did one of the jumps, still several versions behind, but that was closer to our goal. So we took that version, we took the original 2.8 version, and we tried to merge these two things into a pseudo Frankenstein monster merge result. So we could have a broker, not that we wanted to release and publish to the public, but something that would allow us to run a broker in which we could test our plugins. So then we could develop our plugins and then see where it was breaking and where it was working and where we needed to do some more development or investigation to solve some bottlenecks. But we weren't alone on that one. We also reached out to the community, and the community reached out to us because they saw what we were doing. And we had several companies approaching us, asking about the status of the development of the project, of the plugin itself. They also asked if they could help, and we said we are more than welcome to help. And one of the ways you could help is by helping at testing this plugin. So we gave them all the tools needed, all our fork that we did to have a broker running, and they started testing, and they started providing us with bug reports. They even tried to solve some of the bug reports they even created. And thanks to that work with the community that we worked together, we managed to have, at the very day of Kafka 3.6 was released, we managed to have a plugin that was working perfectly fine together with the code. And that was thanks to the experiments we did before, also with the work with the community that helped us test that, so we didn't have something completely untested out of the door, but something that was already running through some testing pipeline, so to say.
This seems to me to be a perfect mix of the OSPO willingness to contribute back to the open source, the community behind Kafka, and the willingness to innovate all together. Still, tier storage seems like to be a first step into something bigger, into maybe changing a little bit the role of Kafka itself. Filip, what do you think about this? Where do you see this kind of tier storage and this process of working more with kind of in a more cloud native way?
Yeah. I would actually refrain a little bit the problem we are facing in streaming data in general. Till this day, streaming data is expensive. It's premium data, right? And the appeal of making streaming data cheaper and more accessible, right, without sacrificing the speed, the latency, and the durability of it is really high, right? So we are seeing a lot of innovation on the horizon, and the appeal of something like the object store, right, which can kind of effectively be this huge infinite hard drive for Kafka without really sacrificing much. It's just this little bit of latency you're adding into the system is obvious, right? So going forward, we see another appeal, right? It's the broader appeal of decoupling storage and compute in general. And I often use the example of the first event of decoupling and storage and compute. This happened actually within very introduction of S3 years ago. This was the time when it actually created the data lake. This was the event that actually gave birth to the new architectures, which are almost 10 years old now today. But this was the capability which enabled customers and companies to store infinite amount of data, to capture infinite amount of data. And I would actually go as far as to say that it is the birthplace also for machine learning and AI, simply because this is where all those algorithms are being trained. This is where the vast majority of the data actually resides. It's in those large, huge stores of Parquet files, right, which are relatively economically viable, right, for companies of all sizes. So it's a natural process that we should think like, what can decoupling of storage and compute can do for streaming? And tier storage is just the beginning, right? We already see the broader trend of the evolution, or the next step of the evolution of the data lake, right, into the so-called lakehouse architectures. And lakehouse architectures are nothing more than bringing the structure of the data warehouse with the data lake economics, right? And it seems like the perfect match and the perfect fit, simply because you will get the same functionalities of those use cases, which are super, super important usually for your business operations, for your analytical layer, but with the economics of your operational layer, right? Right there in the bucket, into the S3 bucket. We are observing a similar trend towards the streaming data. So we are seeing certain first attempts already in the industry and in the broader community where people are saying like, why do you need local disks, right? Why do you actually need to keep this, let's call it aging design, right, of data streaming? We already discussed the legacy, right? It was built first for the data center. Why not actually lean into the cloud rather than attempt to do lifts and shifts, right? Because this is something which we all struggle with, right? And I think it provides a massive opportunity going forward.
I want to double down on
Sure.
something that you said. You said a magic word for me. I've been for years in the data space, and you said the word Parquet. I believe this is a key concept to dig on, and probably a nice question for Josep as well. Tier storage as of now writes to a new disk something that only Kafka can understand. While Filip was talking about Parquet, which is a format that is used by analytical tools, by data tools. So how are we going to evolve? Or should we evolve our tier storage to talk not only Kafka language, but to talk a huge variety of languages?
So we can go in different ways, and we can just break the problem into different chunks. So we could potentially go crazy or all in and make Kafka understand Parquet format. And that could be probably the craziest route, because probably it's the one that will never be done, or the one that will have more obstacles to be made. Kafka has its own format, and it understands that format, and it's optimized. Kafka is optimized to have this format, and that's the fastest way that they can write and read. So having all the formats might not be as effective. However, things could be explored. There is another way, which is, as we mentioned, like how it works is you have the local broker. The broker at one point in time reaches a moment where it detects that that data should go out of the local disk and should be pushed to remote storage. So it could be pushed to this remote storage. Then it's when the plugin comes into play. The plugin does whatever you want it to do. So potentially you could get the data, translate it to Parquet format, and write it whatever you want. The only problem would be when you want to retrieve this data again, and you ask the broker, can you give me a piece of data, please, that is way back in the past? The broker will realize, oh, I don't have this thing on the disk anymore. Let me ask the plugin to give me this data back. And the plugin will retrieve this data, but it will not be in a format that Kafka can understand anymore. So how can you first understand which segment you need to read from there? So you need to translate that segment concept from Kafka, as in which positions are we, offsets, I'm reading from that offset of that other offset.
Which point in time you want to read from.
Exactly. And you need to translate that to a Parquet understandable concept. So you would need to have this immediate layer of understanding what data are you wanting to retrieve. But then again, the data itself, you need to translate it back to something that Kafka can understand and read and consume back. But that's potentially doable with a lot of translation layer on the lower end of the plugin. You could potentially do that. And that enables that what you write on the storage is Parquet. Well, whoever reads Parquet from the other side, it's up to you. Then it's where Filip comes and start making business out of that one.
Yeah, I just want to drive something, again, just going back to the lakehouse discussion. There is a lot of hype also around this topic, right? And we all hear it, we all read about it. And I just want to mention something important. It is very, very known in our industry that data lake type of workloads are just part of what actually Kafka does. And to my knowledge, it's not the largest piece of the Kafka workloads. Kafka is great at carrying logs, metrics, security events, right? At great speed and great volume. Big data, right? Stuff which you do not really care if it's a little bit out of order or maybe you missed a piece here and there. It's just great because it's such a huge pipe, right? You can basically throw anything at it and it will just go. Data lake workloads are just usually piece of this, right? And the important bit here is whatever we want to call this going forward, whether this is a streaming lake, stream house, or whatever, is we need to understand that the stuff behind what we are saying is Kafka is becoming more and more source of truth. And I always use this example. The only thing which offers 100 times faster and better performance compared to RESTful API communication, compared to database replication, is data streaming. And I hate to say this because it's an overloaded discussion, but we're going into the AI era, right? And big data in 5 years will be nothing compared to what we have. And we just need the tools to handle this. So the only tool out there to actually serve the needs, 5 years from now, is actually data streaming. Whether there will be lakehouse workloads and it will be with the lakehouse economics is definitely something very appealing going forward.
And I believe you make two very good points. The first one being the unique source of truth. Again, being in the data business for long enough, I've seen the same data replicated in 5 different locations with 5 different KPIs given to 10 different personas. And that's a problem for the business. The other bit is about a fast way to ingest the data and to make the data, what Josep were saying, accessible not only to Kafka, but to a wider audience. I believe the combination of the two will make kind of Kafka the first citizen in kind of data movement and data sharing as well. So a question back to you, Filip. What are the use cases that company will use this for? I mean, we talk about technology. What's for the business?
Yeah, that's a great question. What's for the business on the lower level is that Kafka is a standard. You can think of it as an API. and it's an open standard. Everything in the world can interoperate with Kafka. And again, going back a little bit to the lakehouse, now if I actually conjure up a few other technologies like Flink, like Iceberg, and Kafka, everything in the world actually interoperates with these. You can think of these as the primitives of the modern data lakehouse. And now going back to the use cases, right? Like, what does this mean to the business? Well, I come from a financial background, and I can expand a little bit on these more. Data streaming really helps companies become real-time companies. We were driving towards a vision for a real-time bank, a company which actually can take its operations and make them real-time. What does this mean? Well, for example, fraud detection. Instead of waiting for a batch job to finish overnight and then block your card after a fraudulent transaction, you can actually get a notification right now. And maybe it's actually even contextual notification. We blocked your card because we noticed something isn't right. Another use case for real-time is real-time customer service. Being able to receive contextual notifications based on whatever usage pattern you have in your mobile banking or web banking is really powerful, especially when you think that there isn't human in the loop. There is a certain algorithm, whether this is something like a machine learning behind the scenes, deciding what to cross-sell to you, what to offer you as help. Maybe they saw that there is insufficient balance in your bank account, and immediately you can have a pop-up because the algorithm knows that you have enough money in your savings account, and it's prompting you, hey, just move the money from your savings to checkings because we notice that you have insufficient balance. This is the power of real-time. Real-time means that we operate at the speed humans do. It's much more natural. It's not after the fact, right? And now if you expand on this, then the use cases is pretty much infinite.
So that's a valid point, and the use cases are there. Like if you want your car to be blocked, you want it now. You don't want it in 5 minutes. You don't want it in 2 hours. At the same time, you stated something key there, that all these are like Kafka, Iceberg, Flink are becoming APIs. So the question that I have for you, Filip, is there the risk for Kafka to become just an API and the Kafka itself going away?
I have a provocative thought about this.
Please.
And I'll start actually backwards. Up until recently, the only way to consume Kafka data was to have a Kafka consumer. And for those who actually know how to work with Kafka, they know that it's non-trivial work to create a consumer with all the logic, be downstream of the data which you kind of like consume and execute on a business case, right? But I say up until now, right? With the adoption of Iceberg and open table formats in general, like Pymon, like Hoodie, and some others, we suddenly see that the need to execute on a specific business logic or a use case may not necessarily need or require a Kafka consumer. Why? Because actually they bring to the table a new primitive, not only a Kafka topic, but also a lakehouse table. So if you're able to produce via Kafka directly into the lakehouse, as we discussed earlier, right, then you will be able to solution your use case with a string of tables to execute on whatever business logic. And this is especially powerful. I call them analytical use cases on Kafka. And I define those use cases as things which can wait a little bit, right? They don't need to be super real time. They're not transactional in nature. Usually there is a human on the other side. Maybe it's a dashboard. Maybe it's a report we run once a day, right? It doesn't really necessarily need like 100 milliseconds of reaction because, getting to the lakehouse as fast as we can try to do it, it will still add latency versus something which is on a local disk, right? It's just physics again. But all those use cases which are non-trivial in terms of share, right, of Kafka workloads definitely can benefit from this new idea, or let's say a new type of data sharing going forward. To that end, I think the future is very bright.
So it's interesting because what you were saying is basically Kafka will be there because even if it will not be there as we know now, the type of workload that Kafka is empowering businesses is still critical and will remain critical. Whether you use only to produce the data with a producer and then store it in several ways, it allows you to then pick the best tool to consume it depending on your needs. I want to jump back a little bit on tier storage itself and Kafka itself. Josep, what can we expect from the community, from the open source Kafka going forward?
So that's a good question. And some of the things that we can expect, they vary from different angles and capacities as well. So what we can expect from the ones who want to improve Kafka tiered storage is to implement some of the missing features that exist. I mean, there are functionalities that they haven't made yet to the implementation because it's a big, possibilities are infinite. So we can continuously improve tiered storage. And we need to keep doing that. So I would call to developers who are interested and who understand the local problem of tiered storage to come around at Kafka and try to improve and enhance the features on tiered storage. Right now, for example, there is a limitation on where you enable tiered storage and you want to disable it again, how you get all the data that you pushed to a tiered storage, how you get it back, if you can get it back, or how you work with compacted topics together with tiered storage. These two things do not work together. So is there a way to solve those? Is there a way to improve these features? So that's one way that the community can obviously help and contribute and collaborate. The other things is just testing what is already there. We did that thing. We find that the existing broker and the existing plugin works for the vast majority of cases for many people. We want to have people with huge workloads to test tiered storage and see how it works for them. Where are the bottlenecks? Are we hitting bottlenecks with certain object storage providers? We know of some theoretical limits that we have on Azure, for example, that we need to work around and create different accounts to be able to store huge amounts of data. So we want to be understanding what are the limitations that people are facing out there. So we want people running tiered storage, testing tiered storage, and reporting back their findings and reporting back their deficiencies or what could be improved for them to adopt this thing in production. Or even running in production and say, it works, but we would need to improve these 2 or 3 things. That's what we would encourage and what I would expect from the community to work and help us, everyone in the Kafka community.
It's basically helping me to help you, or
Correct.
The opposite.
Yeah, so basically we need to work together on what do you need, what's breaking on your end, so we can together work on fixing those things. The happier you are, the better product we have. Yep. And I'm not talking just about Ivan, I'm talking about the Apache Kafka tiered storage solution for everyone, the Ivan plugin together with the Apache Kafka. So how we can have a holistic solution that provides a solution to a problem that real people have, real businesses have.
You know, this is always coming from a community initiative. It's open source Kafka and possibly going into the lakehouse. So Filip, a question for you. I'm skeptical by nature. I want to understand things. How can you tell me that lakehouse is something that is for the future? And how can you tell me that it's not just a bubble?
I can tell you that I've seen things.
Okay.
And
lottery numbers as well.
and the way I think about it is you can build practically any business on topics, jobs, and tables. Of course, querying, processing is needed to be there. Transformations, let's call it data transformations, right? And a lot of connectors and schema registry, but not much beyond this. I truly believe that technology is successful when on the very low level is extremely versatile. And this is what I'm seeing here, extreme versatility. To the point where if we look closely to the different open table formats, Kafka ecosystem or Flink ecosystem, we see such an amazing versatility. These, let's not forget, these are best of breed, right, in our communities. And they interoperate with anything out there. they can plug in and they can be industrialized, right? Companies can industrialize around these, let's say, these technologies. So I firmly believe that these are the future primitives of the lakehouse.
So you can build any business based on basically what we are talking about, Kafka plus tier storage, which is basically giving the ability to have tables under the hood and some stream processing.
I wouldn't call it tier storage, but object storage, 100%.
Okay.
Yes.
The final question that I have for you, Filip, is what do we need? What is in your wish list to have a booming of adoption of these features?
I was about to answer very quickly metadata, and taking care of the metadata and making sure that we pay the tax of converting what Josep was saying, the rows to columns, sorted out on a community level. Because, there are many ways to pay the tax of conversion. You can do it maybe with the connector, maybe with Flink, maybe you can do something proprietary, right? There are many ways. But I wouldn't say that this is a big problem. My actual answer to your question is more on the open table formats. Most of those open table formats, with the exception, I think, of Paimon, are coming from the batch era. And they have been actually optimized extremely heavily for these types of workloads, right? So in a world of streaming, there are certain discussions already happening. We call it the small file problem, right? Streaming is extremely fast, but it speaks small files, right? Small changes, incremental changes. And these things do not really go well when it comes to query performance, right? You need to constantly run compaction. In plain terms, it means that I need to burn a lot of compute to make sure that actually what I'm producing in this table is economically viable for me versus just consuming it with a Kafka consumer, because we need to also add the cost of querying. So I would say that advances in the open table formats will completely and utterly remove the barriers, right? Because as I already mentioned, Kafka is mostly already there as a source of truth, right? We just need to punch a giant hole right into the lake and make sure that we don't have bottlenecks downstream. Right, so I am expecting and wishing for downstream innovation in this specific context to make sure that streaming is a first-class citizen. I think you mentioned it in the beginning. I think this is the key to everything.
And it's a cool thing because I believe we are ready to pump the data. We just need the lake to be ready to receive.
Ready to receive, exactly. Yes.
So, last question for you, Josep. What would you like to see in the next Kafka release?
I like to see a lot of things. I would like to see things outside of tiered storage. I would like to see things in the tiered storage. So I would like to see new features or improvements on the existing tiered storage features. So, for example, I know that quotas will make it into the next release of Kafka tiered storage. So that's a nice feature, a nice addition.
What does quota means?
As in, you can define the quota of how much you can write on certain object storages. So that's a KIP that was approved recently. So that's something that probably will happen on the next releases. But one of the things that I would like to see in the next features is probably how to seamlessly recover data from upstream. So from this storage data that was already tiered, how you can untier data, because that's a key thing for experiments. You might want to try things, or you might realize that you tiered too much data into the tiered storage and you want to untier some of that one because you needed that data. Maybe you need something, you need to recover that data back onto the really fast disks. So that would be a nice feature that I would like to see. This will not make it in the next releases, I can tell you that. That's not in development yet, but that's something that I would like to see in the future releases.
I believe this is a good idea of enabling more experimentation about it.
Correct.
And will probably help more companies, more people to experiment and give feedback also about tier storage itself.
Correct.
Well, Filip, Josep, it was a real pleasure. I believe we learned a little bit about tier storage itself, but I learned a lot about how to understand the key role of Kafka now and in the future, and how we can make the data passing through Kafka accessible to a wide set of tools. So it has been a pleasure having you here. Thank you very much.
Thank you for having us.
Thank you.
That was a really great discussion you had with Josep and Filip. Having a background in data for 15 years, I'd love to hear your top 2 favorite topics from that discussion.
My top 2 picks will be into 2 very different directions. On one side, we witness it, why and how the community can come together in order to build something useful for everybody. The example from Josep and the OSPO team working together with the community, together with other counterparts, into building or bringing tier storage in the open source Kafka is a win for everybody that is using Kafka now. Everybody that is using Kafka, no matter where they are running, they have the broker settings and they have the plugins to deliver or to use tier storage. And then we have the other part of it, which is from Filip and Josep's words, understanding the changing role of Kafka. Because we, as of now, think that Kafka is the ingestion and the consuming part, and it's only streaming mode. While with this idea of tier storage and the evolution into some sort of lakehouse, we have the ability to use Kafka for the ingestion part, which is really good at it. And then, depending on our needs, use the tier storage, the lakehouse, Apache Iceberg, Parquet, you name it, to have different approaches to how we consume the data. Is it in streaming mode? We will still use a Kafka consumer. Is it more batch-oriented mode or micro-batching? We can use the Parquet file, the Iceberg tables, in order to do another type of workload. It's about giving the flexibility. And the last bit is hearing what Filip said, that Kafka is ready to pump the data and is waiting for the open table formats to evolve to be able to support that. This speaks a lot about the maturity of the Kafka solution that is able to really be the backbone of data companies now. And in its evolution, is able to not only stream data, but serve the data to all the companies in the format that they need to use to work with.
When I was listening, my favorite part was actually just the example. It was so clear with that bucket with if you put a hole in it, it's just flowing down. But then when Filip, I think it was Filip who said it, but imagine a pump on it. And I thought that was a really good visual example.
Yeah, I mean, streaming platforms technology can be hard, but sometimes you just have to go back to the basics and everything becomes simple again. I believe also this is where Kafka is going. Reducing complexity, allowing people to use their data depending on their needs is what we will see in the future of Kafka, of streaming, and with the lakehouse.
I actually wanted to ask you a question that you asked Filip, but I want to get your take on it. And what you asked him was, do you see Kafka being just an API?
Well, just an API, I believe it's not a good way of framing it, because I would say it probably will become an API. Being an API means that you are so successful that people use the common way of calling you to call every other streaming use case or every other use case. And I would say it speaks to the success of the project itself. Is Kafka going to become an API? Well, we see in the market that there are already what is called Kafka-compatible solutions. But at the end of the day, the role of data will be to be the data backbone of companies, being able to take the data from where it is to where it needs to be in kind of streaming mode with low latency and high throughput.
And you're right. Become an API is a better way to phrase what I said than when I said just. So I agree. Well, thanks so much. I'm glad that you were able to sit down with them, and it was such a great conversation. I'm excited for others to hear it.
Yeah, absolutely.